Okay, so for today, we're going to talk about files and exception handling. So this one is also very important. So previously, we have covered data types, data structure, functions, and classes. But if you're doing geospatial, we're dealing with a lot of spatial data. So at the end, you will need to actually read some data, write some data, read some data from your local drive, read data from the internet, download some data, and then do some data processing. And for this lecture here, we're just going to deal with some simple plain text file, for example, GeoJSON or CSV file. But this is just using the built-in Python functions. It's nothing unique and nothing complicated. And so pretty much this is the last lecture covering the Python basics. Starting from next week, we're going to talk about, for example, NumPy and Pandas. Those are more like third-party libraries, not the Python built-in libraries. So we're going to introduce more, and this is where it becomes really, really powerful because you can write program that build on top of other people's work. Okay, and after that, after next Tuesday, next lecture, then we're going to really geospatial. So for now, it's not really geospatial yet, although we are dealing with all the coordinates, reading the files, but those are pretty much, you don't really need geospatial packages. We're just using built-in Python packages. But it's important because it's the basics of basically the foundation of other geospatial packages. Under the hood, they might using this basic functionality to read the file, open the file, although it can be just doing one line of code. Right now, you might need to write a couple lines. But still, it's important to understand. And also, exception handling is like when you write a program, make sure that you can think about all kind of use cases, all kind of scenario. For example, if you design a program for user to enter their social security number, right? You need to make sure that the number is entered in a correct format. You cannot just enter any random numbers. You can only have 9 digits, right? You cannot enter number characters. You cannot enter other special characters or floating point or whatever. It must be integer, 9 digits, for example. So how do you make sure that the user entered the correctly? If it doesn't, you should pop up a message saying that, oh, it's incorrect, right? So just like whenever you go shopping, you enter your credit card, all the system are going to tell you, okay, this is incorrect. This card doesn't exist, or this number is not valid. Or enter the address or the zip code, they're going to automatically make correction, right? If you go online to do shopping, it happens all the time. So behind the scene, they are programmed to check those things. And this is where exception handling is useful because you don't want that user enter something and your program just crash. And then they need to reboot the system or close the browser. Then it's a very bad user experience, right? So you need to handle that. If it's something that's invalid, you give a message and then they can correct that rather than fail the entire program. And so this is where exception handling can be useful. Okay, and we're going to talk about different use cases. And this is, if you use any third-party packages, this is going to be used all the time because you need to capture those errors and then deal with each individual one if needed. All right, so download the notebook, clone the repo. So we're going to get started here from VS Code. And there are different ways. So when you are handling the file, you can create a file or you can download the files from somewhere. So for this lecture, we first want to create a file and then so we can read some information from the file. So let's look at this program here. This is a simple one. And so we're going to use some sample data, sample coordinates here. You might notice here we have triple quotes, okay? So triple quotes is similar to single quote, double quotes, but triple quote allows you to wrap multiple lines of text, okay? Multiple lines of text, so they just being treated as like a long string, but it can be multi-line. So in here, we have triple quotes, and then going to have 1, 2, 3, 4, 5 lines of text. And we are going to define the name, for example, output file name. So this is the file name we're going to utilize. And this one here, this code block is both doing the file creation, but also exception handling. So what does this really mean? Forget about the trial first here. Let's look at this one, this line. And this may be the example, first example using the which statement. Which statement means this is so-called a context manager. That means we are opening the file and we are going to indent any lines within there. So we're going to open the file and then we're going to write the file. And whenever you go to the exit this code block, it's going to close the file automatically. I'm not sure if you understand that, right? So if you open, for example, a Microsoft Word document on your Windows computer, you're doing something, eventually you need to Control Save, right? Control S, and then you close the file. But sometimes if there's power outage or something, it will just close without, it's not closed properly. Make sense? So this with statement here is to make sure that your program can close the files properly. But you don't necessarily have to use this one. You can do it like this. So I'm going to show you, for example, here, I can say open. So open is a function, a built-in function of Python. And then I can do here, for example, coordinates .txt. And just like that. So you can assign this one to a variable. So f equal to something to open. That's it. But you need to make sure that f dot close. So you have to manually close the file. If you're using a with statement, you don't have to close it. So you always make sure that it closes properly. So this is the recommended way of opening any files. And so the first parameter here, you press shift, no, shift that. If you have your mouse over here, and it's going to tell you, okay, the file. And then the second one is the mode. The mode by default is R. R means read only, okay? Read R. But you can have other like W. For example, here W, open for writing. You can have X, create the file and open for writing, or A. But most of the time, you can just use this, either one of those. So read means you're going to read the file that already exists. W is going to basically create a file, and it's going to overwrite. So if you have the file name already, the file already exists. If you use the W mode, it's going to delete your file and then create an empty one. So you need to be very careful about what you want to do. If you want to read the file content, you read the file content. If you need to read the file content and also write the file, then you can use, for example, open the file for writing. You can also append things into the existing file. So I want to talk about some of those use cases in here. For this example, we're using the W. So that means, okay, we have these 5 lines of text. We want to write this one into a new file. And so we define, okay, this is the file name I'm going to use. Then I'm going to open this file. It's up to you. This one doesn't matter. So this is basically just a so-called a file handler. It can be, you can change it to something else. For example, the easiest way will be usually just say its open file is if, if. So you can think about this just a pointer, the file, so-called file handler, pointing to that file. So just make sure that it's consistent. You can say if, you can use file, is whatever you want. And then once the file is open, there's a function called write. Write means, okay, it's kind of like we are simulating what we do manually. So it's something like this, okay? I'm going to copy, for example, these 5 lines of code. And then, so without programming, this is what you do, right? So I'm going to open, for example, go to my downloads directory. And then usually you just say right click, new, right? And then from here, you can just do txt. So I can say coordinate, right? You create a new txt file, open it, double click, and paste it, right? Control S, close. So this is what you do if you don't know programming, right? So right now what we're trying to simulate is we're going to use Python to write it automatically, right? So imagine you have to like create 100 files and then you need to loop through them. It's going to take you a lot of time. But programming, seconds, anytime, just do a looping. So what we are doing here, again, make sure you understand logic. We have this content we want to write. We define what the file name, right? And then this is going to open the file and then just write the content directly into the file. And with the with statement, I don't have to worry about if the file is closed or not. It's going to close automatically once the program exit from this code block, right? So right now, after that, it's going to say, okay, sample files have been created successfully, blah, blah. If something is wrong, it's going to say something is wrong. So, for example, here, right now I already have these two files. Let me delete them so that you, let me delete these two files. And you will note, you will see that when the file is created. Okay, so I'm going to go back to here right now. The file doesn't exist yet. So if I execute this code block, pay attention to the left side, the table content. See the file has been created and it's here. So it's the same as what I showed you earlier, created manually, but right now we are doing programming to create a file. And so you will see here try except. So this is where you can handle if something goes wrong. So without that, the program will fail and then you cannot continue. So it's better to capture the error. So I'm going to show you here when you will throw errors. So for example, if the file doesn't exist, if the file path is wrong, you're not going to be able to create a file. So let me create a new code block just to show you an example when it's going to fail. So let me copy this one, just the initial code block here, and I'm going to demonstrate when you will fail, what it looks like to be failing, right? So without the try and except code block, your program look like this. So I have the text, and then I'm going to open the file. It's going to make some changes, and then you're going to write. So for example, right now, if I click this one, you see it's fine. You can write as many times as you want. This file is going to be deleted and created all the time because we're using the WMO. Make sense? But if you use the, if you need to write the file, then you need to use the WMO. But if you just want to read, you'll be f.read and then read the file. So we'll talk about the read later. For now, take a look at this one. This is the file path. So if you just write the file name, make sure you pay attention. You just write the file name without the file path. It's going to save to your current working directory. Okay. Right now, our notebook is under this here Python directory. So you're going to save to this current directory in here. But you can save to any other directory you want. It doesn't have to be a current directory. But if you accidentally do something like this, okay, slash, for example, data, something like this, okay. So slash data and then the coordinates. So what happens if I run this one? What do you think? Oops. This is where it happens. This is where it has the error. File not found error. So why? Why we cannot find the file? Because this file path doesn't exist. So if you have a slash at the beginning, those are usually Mac and Linux file paths. Start with a slash at the very beginning. On Windows, it doesn't look like that. But how about we delete this one? Would that work? It still doesn't work. So why? It's going to say no such folder or directory, data, blah, blah. Because under, right now, my directory in here, there's no a directory called data and beneath this one. So if you need to go to new folder and then data. So if you run this one again, now it should work. Okay, and now we have this folder inside. So when you're trying to open the file, it doesn't create the subdirectory. So if the subdirectory doesn't exist, it will fail. And as you noticed earlier, right, it failed. That's no good. Your program just stops. So instead of like just throwing errors, you capture the error. So this is, if you, let me change this one, right? I'm just going to show you one more time. So change data to, I'm going to throw the error. So look at this one, the red color, file not found error. So this is the Python error type. So you can encounter, okay, if the file doesn't exist, you throw this error saying the file doesn't exist. If the file is being locked or if the file has already been opened by somebody else, then you say the file has been locked. This is kind of when you use desktop GIS, for example, ArcGIS. You open a swap file and you open another program, you try to open the same one, it's going to tell you right now it's locked and blah, blah. You cannot edit the file simultaneously. So this is under who is doing something like this. So make sure you capture the error. And the other thing I want to mention here, as I mentioned, if I don't put the file path, just the file name like this, it's going to save to your current directory. But if you want to save somewhere else, for example, I want to save it to my C drive. So you can do it like this. You probably need to go to your, where is it, your username. So you need the full file path. So for example, user, and then my name, and then downloads, for example. So from here, you can copy this file path. Okay, but let's see if it works or not. Okay, I'm going to copy this one, and I'm going to paste this one here, and then backslash. So what do you think? Is this the file path? Does it exist? Let's run it, see if it works. Oops, what happened? Sounds like right? It's the absolute file path. So what does this mean? Syntax error. Unicode escape, blah, blah, blah. I don't know what does that mean. I assume most of you are using Windows. You're gonna encounter this one, okay, 100% when you are dealing with file paths. Because Python programming, it works nicely on Mac and Linux because all the file paths using /. Okay, Windows is using /. So // is not good. If you read what we cover in the one of first or second lecture, the backslash has some special meaning, right? \n/t. So file path is no good to use backslash. But if you really want it, so in all the Windows operating system, if you're dealing with file path, you want to put an R at the beginning. R at the beginning, R means raw. So you want to treat this one as the raw string rather than as the backslash. Make sense? So just whenever dealing with file paths on Windows, if it is absolute file path, put an R at the beginning. As long as your file path has a backslash in Python has a special meaning. It's not for file paths. But if you want to use the file path, put an R at the beginning. Okay, so now look at this one. I'm going to go back to my Windows file path in here. Let me delete this one. And let's run this one again, see if it works. Okay, cool. Open, see? File has been created successfully. So this is one way you can handle the file path. The other one, if you really don't want the R, then you can either change this one to from backslash to /. Then it will work. Or you can have double backslash. So sometimes you might see something like this, double slash. But if you have a very long file path, you need to replicate all the backslash. It's easier just to put an R at the beginning, so you don't have to deal with this one. So this one is another file. It should work also. Oops. Oh, I miss. I have a typo in here, so it'll be backslash. What? Oh, user. Okay. Yes. Now it should work. So either double backslash, /, or you can use /, but put an R at the beginning. So the easiest way is R at the beginning. Okay, so make sure you understand this one. For beginners, sometimes like, what is happening? The file path exists. Why it doesn't allow me to save? Because the escape sign has special meaning on Windows. All right, so this is how you create a file. Next, let's talk about how you read the file. So assume that, okay, we already created a file here, coordinates.txt. And so next, let's read the file. So I'm going to read the file from this coordinates.txt, and then I'm going to output another new file. And this is the power of using programming, is you can read any file, and then you can do some data processing. You can output the result to something else. And similarly, we're going to use this try except in here. So if you remember earlier, when the file doesn't exist, this is called except file not found error. So if the file doesn't exist, it's going to print out a message rather than failing the program. So it's better to give some messages rather than just shut down everything. So you're going to put this within the code block. So try. When do you want to use this try except? Is whenever you're programming, you expect that your program is going to encounter some errors. User might enter something incorrectly, or something potentially may fail. Then you want to put that within a try so that you can capture the error. And so right now, pay attention to here, right? So we already have the file, the coordinates.txt. Look at this code block. So we're going to indent this one, and then we're going to open the file. So now look at this one. R means read. Okay, so I'm going to open the file. This is called in file, and then we're going to use this one called read lines. Read line means I'm going to open the file, read all the contents as lines. So you're going to, if you have 5 lines, you're going to have a list of 5 lines. We look at the contents later, but this is just basically open the file, read all the contents, and then I'm going to create a new file, and I'm going to look through the content while read from the input. Okay, so the input has 5 lines, and I'm going to loop through each line, and then I'm going to get the output from each line, and then I'm going to put into another line. Okay, so here for each line, I'm going to split, remove the. So what it is doing here is, okay, read each line, get the number, split this by comma, and then get the coordinates, and then put into another file. But I want it to be a spatial format. Looks like this. Okay, latitude, and then colon the number, longitude, colon number, something like that. And if after you're done, you're going to create a new file. So let's look at the content first. So run this one, and then look at this. Make sense? So it's basically converting from this file and generating something like this. So you have a spatial formatting. For example, I can have a file containing numbers and then latitude, longitude, and then with north and north represent north, south, west, and east with those characters in those numbers, in those coordinates. But I just want the numbers, and they need to convert to negative or positive or something like that. Then you need to do the data processing. So what we're doing here is, okay, read this line, and then separate it by comma, and then so you get these two numbers, and then you can format the number. So in here I can put the latitude, then fill in the number, put the longitude, fill in the number, so that in that way you have different format. So this is what this one is doing, right? And this is the whole point of when do you want to capture the exception. So right now I can run as many times as you want. It will not run into errors because this file, right, it exists all the time. But right now, if I say change coordinates to input file coordinates to.txt, what do you think? It doesn't exist, right? So it's going to be basically come to here, expect this one. So run it, you see, error, the file coordinates does not found, right? So if you don't know how the program is being executed, again, you're always welcome to use the breakpoints, and it's going to tell you line by line what that is doing. Right now, if I execute this one, and then I'm going to say debug the cell, and right, so right now we can do the debugging. So you can step into this one. So the first line, create a variable, second one, and then it's going to try except. So look at this one, with open, right? It's going to go to open the file. If the file doesn't exist, see where it's going. See, it's going to come to here, and this is except file not found, because earlier we show you if the file doesn't exist, it's this type of error. Then I'm going to print out the message, and then you're going to finish, right? So if the file exists, see what happened. So let me go back here and then do it one more time. Create the breakpoints, and then debug the cell again. So in this way, the file is it does exist. So now the program is going to run differently. So again, I'm going to step into input file, output file, and then okay, I'm going to open the file and look at this one. So now we are reading all the coordinates. So the coordinates basically is a list. So on the left side here, if you look into this one, so right now basically the file is the coordinates is a list, a variable of this type variable, and within it you have 5 lines, right? And each line is basically just a text. So everything we read from here is txt, okay? It's not numbers, but you need to split the text, take the numbers, and then you can put the numbers into another file. So in here, and after read the file, you can continue to step into, right? So again, we open the file, and now because this coordinates the list of 5 items, we're going to loop through the item, and for the line, right? So for this time, it's going to be this one, right? Right now is a txt, right? No string, and what it's doing here is going to remove the spaces at the beginning and the end. Then it's going to split it by comma. Then you're going to get the latitude and longitude. After that, it's going to write. So when you open the file, you can write one line, write another line, write another line. You can write continuously. One thing you need to pay attention is here. There's a \n at the end. So you really need to pay attention to this one. When you are writing the file, if your text doesn't have this \n, it's going to continue on the first line. So your file is going to look different. So make sure that you pay attention. So Right now, let me skip this one, and I'm going to show you the differences if you don't use the \n. See what happens. This is what it looks like, right? Pretty nice. And it's going to be very different if you remove this one. So files.write. So basically, you have to read the file. Your cursor is at the end of the first line. If you're trying to write the second line, if you don't have like hit enter, go to the next line, it's going to continue. So let me run this one again and open the file. See, this is not what you want, right? So the problem is that in programming, when you're writing something, you need to explicitly saying that, okay, hit enter, go to the next line, create a new line. Otherwise, you're going to mess up your data format. So, and again, make sure you understand this one. So we're opening the file. We read all the lines all together as a list, and then we are looping through the list. So for each item in the list, we're going to extract the numbers, and then we're going to print that into the new file, and then go to the second line, and then grab that, and then get the number, print to the second, and do all kind of things like this. Yes? R basically means mode. So you can open the file in read mode. R means read. W means write. So if you're opening the file in read mode, that means you cannot make changes. So it depends on what you want to do with the file. If you just want to open the file, see the content, then you use the by default is R. But if you want to open the file, you want to make changes, then use W. W means you're going to delete the file and also remove the content. And there's another mode that might be useful is the A mode. So if you scroll down here, right, A means open the file and then append the content. So let's pay attention, like let's try it out. For example, I'm going to have A for this one, okay? So right now this file already exists, right? Make sense? It already exists. So you can run again. For example, right now I run one time. See? It's opening the file, it's appending the content. So if you run again, run again, run again. See what's happening? So it's not overwrites. But if you use W, it's going to overwrite every time. So it means it's going to delete the file and then create a new content. So it depends on what you want, right? So if you just want a new file, then you use W. So right now, if I change to W, I run again. See? Every time will be the same because the source code doesn't change. So I can run as many times as I want. The file content will not change because it's basically clean up everything and then create a new file, write the content. But you cannot use A, okay? If you use R here, it won't work. Okay? If this R, there's no read, there's no write function because if you're going to read the file, you cannot write the content. So if I run this one, it's going to run into error. So right now, this is the problem. My program cannot capture this error. Your program failed right now because I only have this one, except file not found. But there's another error here, unsupported operation. This is another type of error. That means, okay, you didn't capture. So what you can improve here, you can do it this way, except unsupported unsupported operation. Okay, maybe it doesn't work. Let me see. Yeah, it doesn't work. Then you will do something like this. You will say except exception as E. So this means like it's a generic error. I don't know, like if the file is not found, I'm going to give you specific message. For all the other errors, it's going to be just exception. So this exception basically just like everything else. And as E, that means it can return the message so they can print it out. So what you can do here is the error, blah, blah, and then you can do it like this. So you can use an F string at the beginning, and then inside here, you can use the square brackets to print out, basically capture whatever error that you may not expect. So right now, if I run this one, right, then not writable. That means right now it comes to here, and I don't know what is not writable. That means, okay, maybe your file is not open in the correct mode. You need to open in the write mode, right? So I can put to W. You can fix your program. Now if I run again, it doesn't matter. Then the file will always be created. Make sense? So reading and writing files are very important. So if you need to read the file, you use the R mode. You don't have to. This one is the default one. So if you don't write it out, it's going to look like this. So for reading the file, there's a two function that's common. One is called read. The other one is called read lines. So read, that means it's going to read all the content as a single long string. Read line is going to read all the lines and then as a list. So let me show you the differences in here. Again, I'm going to say the input file, and then I'm going to use this one with open. Let me just pay attention to here. Okay. All right. So these are three lines. So if you need to read the file, it will be something like this. With open the file is a file handler, and then the file handler will read all the file. So just three lines of code, and now you have access to these coordinates. So this one here, if you want to print out, take a look. It's basically a list. And see what's at the end? Let's express \n, because in the file here, you don't see that, but there's a \n at the end. And right now, if you want to read the content, that's why you use the strip, remove the \n at the end. So right now, for example, I can show you here, it's pretty intelligent, so I don't need to write. It tells me like that, like line strip for lines and in coordinates, and you return this one. Now I print out the coordinates. OR. Okay, it's gone. So you need to remove that. So the read lines is for reading them as a list. And there's another one called read. So I do want you to see the differences of these two, right? So just read. Then you're going to open the file, read all the content all at once, and it's going to return as a long string. So right now, if I run this one, take a look, print out the coordinates. See this? It's different. So this one is a long string, but you'll see the \n at the end in there. And the read line, so if you need to loop through the lines, you use the read lines. You just want to get all the content, then you can just use the .read. So in that way, you can, it depends on what you want. So for example, let me just do it differently, right? So if your goal is to count, for example, how many times does it appear in that. So for example, I can say NYC, Knoxville, okay, Nashville, NYC, something like this. So if your file contains like content like this, and you want to figure out, for example, how many cities in there. So what do you think? Do you think it's easier to use the read lines, or is it easier to use read? What do you think? Which way is better? Probably similar. It's not going to make too much difference. You can read it as a long string, so let's like try different ways. So right now, like similar in here, I can write the same line and then print it out. So seeing here, NYC, Knoxville, right? You see the \n? This is so confusing. So you need to make sure that you understand \n in there's just a new line. So if you need to count, for example, how many times NYC appear, then it will be this right now is a variable, it's a string, right? So you can just stop count, right? And then here you can just say NYC twice. Just one line, right? You don't need to really do anything. But if you need to figure out how many cities in there, how many unique cities in there, then the long string, this one is like not really helpful. You want to split them, and then you want to get the list, but you want to create a set, remove the duplicates. You can still do it just within one line of code. So, but in this case, you want to use the read lines, right? Better. And so just print this one out. So see this one right now? So how do we count how many unique cities in here? So what do you think we need to do first? Remember what we did earlier? First, you need to remove the \n at the beginning, right? Otherwise, you're going to \n is going to treat it as a unique one. So again, coordinates, right? So right now I have a list. So how do we count how many unique items in the list? Right, it's just a set, right? So it's just simple, just a set. There you go. 3 lines of code. 2 lines of code actually. Right? So you see how simple it is. And it doesn't matter. It can be 100 cities, it can be 1,000. You can do it like same way. So depends on what you want. think about whether you want to read the text as a long string or you want to read it every line as one item in the list. So if you need to loop through like line by line, then it's read lines. But if you just need to treat it as a text just to count like how many times does a certain character appear, something like that, then it's okay to use a long, just a long string. So this is how you can read files, write files. So if you read, use the R mode. You need to write the file, use the W mode. And then you can do the exception handling. We already covered it, right? So here, for example, if your file contains something like have some invalid characters, then you do need to be careful. So we are designing the function in here, and we're going to grab the number, get the number, and then we're going to basically process, extract the number. So this is a function. So if you give me a one line of text, I'm going to extract the latitude and longitude. But your data need to be in the correct format, right? It's going to be latitude first, latitude, comma, and then longitude. But if the things that you provide to me is not in the correct format, then you need to handle that. Otherwise, this is so-called data cleaning. In pretty much most of the geospatial program, you're getting the data from somewhere, you need to clean up the data. So if the data is not in the correct format, you either correct like by yourself or you need to print out a message saying that something is wrong. So look at this function here. So you give me a line. I'm going to remove the whatever special characters at the beginning and the end. Then I'm going to split by comma. And the first one I'm going to convert to a floating point as latitude. The next one is longitude. Then I'm going to return the latitude and longitude to me. So this is basically give me text. I will give you the numbers, right? And if the value is invalid, we're going to say, okay, blah, blah, value invalid, or there's any other exception, you're going to capture another exception. So right now, okay, I'm going to give you this line. It says invalid data, right? And you can process that. So what happened? Not enough values to unpack. Expect 2. Got 1. So why? So where does this message actually coming from? Again, if you don't know, you're also welcome to here, debug, and then start debugging. So this see where it actually failed, how the program is executing. So I'm going to go to this one. Again, function definition is not executed until the function is being called by the program. So right now, it skipped and then go to this line. Line equal to invalid data, so it's just a simple string. And so you're going to call this function, then it's going to go back to the function. Now, we're trying to split. So look at this one here. This is a line, a strip, and then dot split. You see? Let's execute. It's just X this one because this line doesn't contain this comma. So if there's no comma, you cannot split it, right? And now it's go to here, and I'm going to say could not pass this line, blah, return none. And then if it's none, then you cannot print it out. It's going to fail your program. So right now this one is none, so it doesn't execute the next line. But if you change the value, so for example, I can say 40 degree latitude and then negative 100, right? Latitude 40 degree, longitude negative 100. So run this one. Nice, works just fine. Why? Because you're going to execute this one, you're going to split by comma, and then it's going to convert this one to 40, the other one to negative 100, and it's going to return the result. So this one is a valid line. So this is how you can design a function to process. For example, you have these many lines of coordinates in here, and you can just process them automatically to figure out whether it's a valid number or not, valid coordinates or not. Again, you can keep trying. For example, you can do it like this. If I remove the comma, 40 and then negative 100, would that work? Yes or no? No, because you're still looking for comma, and it's going to still saying that not enough to unpack because you're looking for comma. But if you really want that, okay, I can come back to here. I can remove the comma. Then by default, it's going to look for space. So in this way, it will work because you're looking for space. So you're separating by space. It's up to you what you want to use. I can also separate by colon, separate by any characters you want. But in your program, you need to design to be able to handle the spatial cases. So sometimes, for example, it's separated by comma, sometimes separated by space. You can treat both cases. Right now, we don't have time to go to give all the examples. But this is just how is traditionally being handled. Is you need to think about the data coming can be a very different format. Different people can create data in different format. You just need to understand and handle that properly. Okay, and also the combined file handling exception altogether is very much similar, right? So you can process the entire file. So you can give me a file. So this function here just give me a line, then a process. But I can give you a file. You can also handle that property. So let me go back to this. The first one, just create all the coordinates again, so that we can utilize. And for example, this is the text file that you have, and I'm asking you to extract all the numbers from the file. And this is what this program is about in here. Where is it? So I'm going to scroll down here. Combine file handling, right? So this is another function. So you give me a file, and then within the file, I'm going to open the file. I'm going to read the file with all the lines, and then for every line, I'm going to process and get the coordinates. If it's valid, I'm going to say print it out and give you a number. If it's not, I'm going to sort out the error. So we run this one. It is not enough to unpack blah blah blah, because yeah, I would change it to comma. So let me change it back here. Again, this one is not working, but right now if I click this one here, so basically opening the file, goes through the content, and then you can process the content. So different from here, with open is a file handler. By default, it's actually reading read lines. Even though I don't specifically saying that read lines is, if you don't do it, it's going to call that function by default. So if you want to be more explicit, you can do it like this. We open the file as something, and then lines equal to in file don't read lines, and then for line in lines. So this might be more readable. Make sense? You open the file, read all the lines, and then just loop through the lines. So these two are equal, the same thing. And look at this. I process all the lines, so 5 lines, but I can add something invalid in there, right? So I can say, for example, accidentally maybe 40, and then negative 100. So see what happened, right? I'm gonna loop through all the lines, and so I can add another one, for example, 39, and then comma, negative 90, right? So I can add 2 more lines, and this is how the program actually handle this one. This we know is all valid, but this one here won't be able to do that because there's no comma, so you're going to run into error. So if your program is not designed to capture the error properly, your program is going to fail. It's not going to process anything after that. But right now, this program is pretty decent, because if the file is not found, I'm doing this. Anything else, I'm going to do this, and then at the end, I'm going to say print out. It's finished processing. So pay attention here. Let me run this one. See, it's going to loop through the line, and then when you get to this line, it's going to say this line, the value is invalid. But you will continue to process the next line, and then it says finish. So that means your program, it doesn't fail. It just skip the one, and then showing you that something is wrong in that line, and then you need to go back to fix it. So right now I know, okay, this line doesn't work. I can come here, add a comma, Control S, and come here, run again. Now everything works properly. So this thing about the file can come from with a different type format, and you need to be able to handle that properly. Otherwise, your program just say error, and then you are done. Okay, so this is about file handling, especially the file, like, it's always going to run into error. Sometimes you're downloading the file from the internet. If it fails, then you need to do something else and throw an error or something. Need to just make sure you handle it properly. So the last example here, this is more geospatial, and this is teaching you how to read the file from the internet. So previously, we are creating the file locally, and then we're reading the file, but most of the time, your program might need some data you don't want to create by yourself. You're going to download from somewhere. So specifically, we're going to download some sample data from my GitHub repo in here. So if you click the link, I have some sample files in here. And if you're trying to read the file, well, I'm going to read this, for example, GeoJSON. So this is a simple 10 text file. You can just click and download it to your computer. But you don't want to do that manually. We want to ask the program to download the file automatically. So what we need is this library called request. So this is a very popular library that used to request file from the internet. So if you import this one, if it doesn't work, then you need to install this one. So if you have installed create the geo environment, it's already been installed. So if there's no error, then you can continue. And then we're going to specify the URL pointing to this one. So now this is the function in here. So I'm going to fetch the file and use the request. So the request library is .get. Request.get basically give me a URL, I will get the content for you. And the content will be returned as an object. And then you can ask, okay, I want the return object to be a JSON, basically a dictionary. A JSON basically means a dictionary. And then within there, I can start doing the data processing. So if there's something going to run into error, it's going to show some of this. So if there's no internet, you're going to basically the file is not accessible, then you're going to run into error. So for example, I will run this one. There's no error, right? So if there's a, for example, if there's a typo somewhere in there, so for example, right? This file doesn't exist, right? Control S. So if I run this one, so right now if I run this one, you're going to say HTTP error occurred, 444 not found error, right? So really nice because it's being captured by this one. So that means your program will handle that error. So right now, I know this file doesn't exist. I'm going to correct that. cities.geojson and run it, and then run this one. So this function is going to get the content from the URL, and then going to return the file, return the content as a dictionary. So right now, this variable here is a dictionary, and you can uncomment this one to see the content. It might take some time because it's downloading the file. So look at this. Right. So this is exactly the same, just like you go to this URL, you double click, you open it, and then you save this file to your computer. Then on the VS Code here, or on the left side, you see I have this world cities.json. And look at this. It's the same content, just like what you are seeing from here. So we are reading the file from the internet, return whatever data format you want. In this case, because it's a GeoJSON, it's a dictionary. We're going to cover more when we talk about GeoPandas next week. It'll be a lot easier. For now, this looks overwhelming. So you're reading the file, and then it looks like this. It's a lot. But this is a structured data format, so we can read the content. And then we can extract the information because it's the dictionary. Then we can use the keys, we can use the list, we can loop through the content to do whatever you want, right? And after that, see here, if the file exists, then I'm going to get the features. The reason why you have the feature because it's a dictionary. So the dictionary have these keys, right? Type, features, that's it. So if you want to see more content, for example, GeoJSON data, and then keys, you see it has two keys. So the type basically means this is the feature collection, just like a swap file. Feature means you have multiple things inside the list. And then inside here, the feature is a list. So basically multiple cities inside this list. And this is what this one is doing here. I'm going to get all the features, and then it's going to tell you how many features in there, right? So similar like this, it will be something like this. For example, features, right? So you're going to get all the content, and it doesn't tell you how many, but it's same as this one, length. The length is going to tell you how many items in the list, right? So right now, 1,249 cities in this GeoJSON file, and exactly like this one. Then I'm going to just print out the first 5, right? So it's a list. I'm going to print out first 5. So inside here is a feature, property, blah, blah. So you can do it like this. So if you just want to see the structure of each feature, then I can have a square bracket and then just 0. Look at this. So this is one item, one city, all the information for this one, right? And again, this one is a dictionary, right? So it's a dictionary of a list of dictionaries, and a dictionary of lists. It gets quite confusing because this is on the nested structure. So again, make sure you understand the logic. Sometimes it can be like, what the heck, this is like too complicated, right? So in here, it's a dictionary, and then here, get all the cities. This is a list. Within the list, for each city, it's another dictionary, right? And then within the dictionary, they also have another list. The coordinates another list. So you need to go all the way down until you can get the content. But this program basically is telling you, I'm going to loop through all the cities, and I'm going to extract the coordinates, extract the name, extract the city, and then I'm going to print out in some kind of format. So this gives you the way to automatically do data processing, data cleaning, and then extract the information, save the things to another file if you. It's a little bit complicated, but I want you to be able to understand it. Just use the debugging and then look through line by line, and you understand what exactly it is doing. Questions? So that's all for today, and I already posted lab 3, so you can start working on lab 3. So lab 3 covers the lecture today and also from last one, functions and classes. So I try to reduce the number of questions to just 6. Used to be 10, but going forward probably just 6 questions, 60 points. So each question is 10 points, and but you can always practice this exercise. All the lab assignment, the quizzes will come from this exercise. I already put a question in advance. So you practice, you can do it just fine. Okay, so that's all for today, and I'll see you in the next